All right, so we're going to talk about chemical reactions. So there are 5 basic types. There are more types, but we'll just concentrate on the 5 basic. So important to remember, a chemical reaction occurs as electrons are either transferred or rearranged, making new compounds. So for chemical reactions, we'll start with them. So the first we'll call a direct combination reaction, many times called a synthesis reaction. The word synthesis means to make. So the important thing here is multiple reactants make one product. So that's the important thing. No matter how many reactants are present, there is only one product. So if you look at this here, I have carbon and CO2 makes 2 molecules of carbon monoxide. So I have 2 reactants here, and I have 1 product. Right? Here I have sodium and chloride, right? And together they make, so I have 2 reactants here, and I have 1 product there. Right? So as long as I have 1 product, and I have more than 1 reactant, it's a synthesis or a combination reaction. Next of our reactions here is our decomposition reaction. Remember, to decompose means to fall apart. So this, I have a single reactant into multiple products. So if I start with a single reactant and I end up with multiple products, right? So again, here I have 1 reactant and I have 2 products, so it's a decomposition. So an example here, if I have 2 water molecules, I add some energy here, and I go ahead and get hydrogen and oxygen gas. I started out with 1 reactant, and I get multiple products. You may also notice that if I did this, right? If I did this, 2 moles of hydrogen gas and 1 mole of oxygen gas makes 2 moles of water. This is a synthesis reaction here, right? So my decomposition is simply the opposite of a synthesis. Okay? So those ones are pretty straightforward. When we get to single replacements, then we got to start thinking a little more. So single replacement, that's our 3rd type of reaction we're going to talk about. All right, so a couple things. The reactants and products both consist of a single element, right? So if you look there, I have a single element in both the reactants and products. If you see that, it might be a single replacement reaction. So that's the first thing you look for. There's a single, right, a single element type in both the reactant and products. Usually it occurs with ionic compounds, right? And you'll talk about that if you're in summer school. You talk about that in 1st semester coming up. If you're in regular chemistry, we've already talked about that. All right, here's an important part. Most occur as being dissolved in water, or what we would say is aqueous. Right, so if it's aqueous, it's in water. So most of these things happen in water. So if it's metals, it's based on what's called the chemical activity of metals. So activity series, for instance, is here at the top. We'll find potassium. At the bottom, we'll find gold. And what it says is potassium is more it's more active than gold. So if I put potassium near gold, potassium would try to transfer electrons to gold, right, to become a potassium ion, because it's more stable as an ion than it is as a metal. So if you put the 2 of these together, because potassium is more active than gold, it would try to transfer its electrons, right? Gold would not try to transfer its electrons to potassium because it's less active. That's why we make jewelry out of gold, right? Because it tends not to lose electrons. All right. So if I had something like this, if I had potassium, metal, right, plus gold nitrate, the potassium, if this was in water, the potassium would try to get rid of its electron to gold. Now the gold here is in its ionic form, right? So if it can gain 2 electrons by 2 of these, if it could gain 2 electrons, right, it could become gold metal again, right? So I do that, and I get gold metal plus potassium nitrate. Right. Now each of these potassiums is an ion because it gave up its electron to gold, and gold now is a metal. Right, so that's a single replacement reaction. The more active replaces the less active. Right. This can also happen with halogens, right? So over in column 7 in your periodic table, right, the second to last, so if we have our periodic table here, right, the second to last column down here are our halogens. Right. So if we take our halogens, at the top of the halogens, right, so actually let me erase all this here. At the top of the halogens, I have fluorine, then I have chlorine, and bromine, and iodine. Right, so those are our main halogens. So the fluorine, this is most electronegative, and then this would be least electronegative. So kind of like the activity series. So electronegativity is the ability of an atom to take the electrons from another atom. Right? So if I put fluorine and iodine together, fluorine would try to take the electrons from iodine. Okay, because it's more electronegative. All right. So if I had, all right, so if I took fluorine and sodium iodide, so right now, sodium iodide, ion, this is an ionic compound. So iodide has an extra electron. I would need 2 of these. So since fluorine is more electronegative, it would take electrons from the iodide. And that would make iodine plus sodium fluoride. Each fluoride here now has the extra electrons because it's more electronegative, so it took it from that. So one last thing, if I had something like this, chlorine plus sodium fluoride, right, I would get no reaction. So this is how, NR is how we say no reaction. Because if you looked up here, fluorine is more electronegative to chloride, or chlorine. So chlorine cannot take an electron from fluoride. It just can't. All right, so that's single replacement. We have a double replacement. All right, so single and double, similar. But you'll know with double now, right, everything in the reactants and products are all compounds, right? This is in water again, so it's aqueous. So these take place in aqueous compounds. And really what's happening here is the metals and nonmetals are swapping, right? So if you look at A combines with D and C combines with B, right? So the metals and nonmetals combine together. Evidence for reaction. Make sure you take notes of these because they'll be on your quiz. Precipitation is solid in solution. Effervescence is gas bubbles. Or at least one product is a molecular compound. So molecular compound means all nonmetals. Ionic compounds are metals and nonmetals joined together. So if you look at your periodic table again, if you have the chemistry, there's a little line Where am I? Okay, there's a little line here going down right here that separates our metals from our non-metals. Okay. All right, so if you look at this example right here, I have calcium bromide and silver nitrate. And you'll notice that the calcium comes over here and the silver joins here. So this is where I would have to use phase description. So these are both aqueous. So aqueous means dissolved in water. But silver, when it combines with bromide, makes a solid, right? So I have two aqueous compounds, and I continue to have an aqueous compound, and then I have a solid. Now that solid is a precipitate, right? Because there's a solid, a reaction's taking place, then it's a double replacement reaction. If this silver bromide was still aqueous, it would be a no reaction. Right. Combustion reaction is our last one. So combustion reactions produce flame and heat, or light and heat, because really a flame is just our visualization of light energy. So I have combustion reaction is our fifth reaction. Double replacement is our fourth. All right, so a couple things here. One of the reactants has to be oxygen, right? One substance combines with oxygen. So right, one of the reactants is O2. It might be a combustion. So if I had this, H2 plus O2 makes water. Not a combustion because I don't get heat and light out of it, right? I just get water. All right. Really, most often it occurs with a hydrocarbon. So burning of hydrocarbons is most common. So if you look at this right here, that's a hydrocarbon, right? Because I have carbon and hydrogen. That's all it's made of. Right? If I have a carbohydrate and water, or hydrocarbon and oxygen, it always produces water and CO2, right? So the products of hydrocarbon and oxygen is always CO2 and water. Okay, so if you look at this reaction here, let me erase some of this stuff, it's kind of busy. Right, so if I look at this reaction here, right, so I have C8H18 plus oxygen makes CO2 and water. Right, so I have my hydrocarbon, my oxygen makes CO2 and water, and light and heat. Right, that's generally a fire. Right, so it's octane plus oxygen produces CO2 and water. Other examples, we just had 4th of July. So magnesium and oxygen makes magnesium oxide plus light and heat. Otherwise known as a sparkler, right? So it still is a combustion reaction because I have oxygen here and it makes light and heat. You might also call it a synthesis reaction because it makes a single product. That's fine as well, right? Sulfur and oxygen does the same thing, right? It makes light and heat when it burns. Flares use that reaction. Okay, so that's our 5 basic reactions. Now you should be able to solve your homework. Remember, there's Zoom coming up if you need help with your homework if you're in summer school, and I'll talk to you soon. Bye.